All right, welcome to SQL in the City. Who's been here before? There's only been one, so. Excellent. All right, we'll get going. This is top tips for better TSQL. It should say queries, but I put in store procedures when I submitted it, so we left it alone. But it doesn't matter. It's not just store procedures. We're talking queries. Here's the goals. I'm going to spend a few minutes, 10, 15, talking about writing for readability. The reason I'm going to do that and not just simply talk about writing for performance is because readability is actually part of performance, but it's not part of the query performance, and the server performance is part of your performance. The faster you can understand what's going on inside of a query, the faster you'll be able to fix it because some other idiot messed it up, right? So we're going to spend some time talking about some best practices around how you write queries and how you name things, and some silly things to avoid. All right, and then we'll talk about performance. So I'm going to talk lots and lots and lots of low-hanging, simple, easy to fix, quick stuff that you should avoid or stop doing. And hopefully my goal is to make at least a few of you quite angry because I'm taking away some of your favorite toys. All right? My name is Grant Fritchey. I work for Redgate Software. This is my contact information. I will put the slide up again at the end. Please use it. I'm publicly exposing it for you, and I want you to use it. Send me an email if you have a question. Get in touch. I'm on Twitter. I have a couple of blogs, and this is the information there for you to use. Here's the agenda. Memorize it. We will be taking a test. All right, writing for readability. Here's the key. I can't tell you what to do. I can make some suggestions. I can give you some ideas. I can expose some horrific pain from my past for you to try to avoid. But the goal has to be for you guys to come up with your own standards. You have to come up with mechanisms that work for you within your environments. You need to achieve some level of consistency on these. You need to document them, and you need to use them. Right? It has to be used. If you come up with some great standard that everyone ignores, it's not a standard. All right? So it's up to you to come up with your local methodology. Now I'm going to talk a little bit about object names, a little bit about comments, a little bit about formatting, error handling, document, and code reviews. Not spending much time on code reviews because I hate them. But sorry. Necessary evil, though. All right. DDL, TBL, diddle tibble. Don't ever do this, all right? Any guesses what that is? No, you're making way too much of an assumption that this has any sense to it. Any other guesses? Done and document later. I like it a lot, actually, but no. Okay, all right. Huh? No, that's actually an object name. Yeah, I'm horrified to say. Your names should not be diddle tibble. Diddle tibble is insane. Diddle tibble is stupid. Diddle tibble is dangerous, and diddle tibble is slowing. Because trying to understand what diddle tibble is, even though eventually you'll understand what diddle tibble is and remember it forever, especially once you know what the secret is, because it's really, really stupid, it causes things to slow down. It hurts your performance. It's going to slow you down. Same thing goes with naming store procedures. Naming these store procedures A, B, C. Naming store procedures update data. Oh, thank you. It's not enough. You need to have descriptive phrases. This is not, and by the way, Oracle people, 1, 2. By the way, British audiences, I know you guys don't raise your hands. I get it. I'm cool with that. But pretend I'm an American. Humor me. Oracle people? Okay, 3, 4. All right, I'm going to insult you now. This isn't Oracle. okay? We can actually name things past 30 characters. All right? Use them. Should you use all 256? No. You know, I'm not saying write a soliloquy for your object names. That's crazy. But also don't do diddle tibble. That's crazy too. Use aliases. I am lazy. I want you to, you must actually, well, okay, must is a big word, but you ought to use table names when you're referring to columns inside of your queries, but who wants to type a 50-character table name every time? So use aliases, but use the aliases in a common sense manner too, right? A, B, C for your table aliases, and it's different tables in every query. Right? This query, it's ABC for table 1, table 2, table 3, and the next one, it's ABC for table X, table Y, and table Z. Boom, splat, right? No, not cool. Don't do that. And be consistent. Document these practices and be consistent. A very, very good friend of mine, and a man I think was actually smart, anytime I would say, okay, we need to be consistent, he would immediately, I mean, it was like on a trigger. A foolish consistency is the hobgoblin of little minds. Yeah, okay, dude, fine. But you know that the operative word in that sentence is not consistency. The operative word in that sentence is foolish. And after today, you can substitute the operative word would be diddle tibble. All right? So, any guesses at diddle tibble anymore before I expose it? No? All right. Deductible. Spell it. D-E-D U-T-I-C-B-L-E, right? Something like that? Where'd the other L come from? Yeah, I don't know. I don't know either. Okay, most of the audience looks, I'm going to offend you all, roughly my age. But a few of you are younger. So for the younger people, explain this real slow. There's these things called dictionaries. Now, we used to keep them in books, all right? Books were paper. It was like this stuff, and it was all bound up. And now they have them online now. So, you know, guys, you can look them up on your own. The dictionaries have definitions for words, and they have spellings for words, and they have one other thing. They have abbreviations. They have standard abbreviations. So if you want to abbreviate words, great. Abbreviate words. You don't need to do diddle tibble. You can do whatever the abbreviation inside the dictionary might be, okay? Please use that, all right? Now let's take a look at a little bit of code. This is just a little tiny snippet of code, and it's just the introduction. And this is very, very common code. I mean, I see stuff like this all the time. Please shout out a few things that make you insane. Or maybe we'll just roll back. Shout out a few things you think might make me insane. I'm not bothered by the star that much. What's that?
%. Because the alias is not defined.
Right. Well, there's an alias. It's just not using the as keyword, which that makes me crazy. Yes, because it's not clear. What else? Without, yeah, I'm referring to columns without referring to the tables. That makes me really crazy. Anything else?
Everything in one line.
Everything in one line, absolutely. Oh. Gosh. Okay, let's keep going. That is pretty bad. Comments. Please, guys, self-documenting code? No, it isn't. I'm sure that your code is good, otherwise you wouldn't be here. If your code was bad, you're the other guys that didn't show up yesterday or today, right? All those people you know that haven't been to either day, yeah, those guys are writing bad code. I get it. But your code is not self-documenting. It is not intuitive. It is not clearly defined without a little bit of comment. Now, the comment I'm suggesting is, what is this thing doing? Not all kinds, you know, oh, well, the last time I edited it, I changed one letter. And the time before that, I added a column. And the time before that, I dropped the column. And the time before that, I added that column back that I dropped. You know, no, that's what source control's for. Manage that stuff through source control, and that's cool. All I really need in comments is, this is the CEO report. Done. Now I'm going to pay attention to this every time I see it. This is, the weekly report run by, the HR department. Okay, cool. When it crashes, I'll think about looking at it. A little bit of information, where it's used, what it does, just something so I know what's going wrong. But remember that self-documenting code is not true. That said, if you're not using good naming conventions and good descriptions of stuff within the code, it's not that it's not self-documenting, but boy is it muddy. It gets less and less clear, right? So you got to go for clarity, but don't assume that you've got complete clarity. You need to add comments. Let's take a look at another piece of code. I see stuff like this all the time, and this is where things start to get fun. From sales order detail A, interjoin sales order detail header as B. Make up your mind. Okay, great. You want to ignore this? Fine, ignore it. Don't put it in one place and not the other. Consistency, just to make it more readable. Also, hang on, I just want to look at the columns real quick. They're on here. There was the one I was looking for. Hang on. Oh, right, there it is. I know that none of you are doing this, although there are a few people looking funny at the moment. Stop, okay? This is just bad. It's hard to read. It's hard to understand. And it's really a pain. I mean, real quick explanation, you haven't saved anything. That carriage return didn't cost any performance hit, all right? Go ahead and use them. It's okay. I know it's an extra character. Don't worry. It'll be all right. It makes things much easier to find and much easier to read if you do this. And by the way, I don't care where you put your comma. Before, after, whatever. That's great. And no, I'm not getting into that religious fight. It's your call. Same thing with stored procedures. This one really flips me out. I go berserk. What are they? Good answer. I wish I had a book to give away. There you go. Good job. Ints, yes. Yes, but what do those ints represent? Yeah, IDs of some sort. Yeah, that's an ID. The first one, the second one, the third one. Assuming my code is self-documenting, I can guess, maybe correctly and maybe incorrectly, that the first one is product ID. Maybe. Don't do this. It's crazy stuff. All right, let's see. Error handling. Who here is primarily still on 2000? Few people. Cool. I am so sorry. You are on your own. None of us can help you. Unless you need help upgrading. 2005 and up, we have try-catch available. A lot of people don't use it. Start. Go home. Okay, it's the weekend. Monday morning, go into the office and start using it. Try-catch is great. Try-catch is actual error handling. Yes, I know. Once the severity is above a certain point, you get a crash. And therefore what? You don't get crashes in code? Developers? Come on, developers. Fess up. Oh, good. Most of the audience. Guys, does your code ever crash? But you still use error handling, yes? Okay. So the TSQL people who say, well, yeah, but because I can't capture every error, what? You can capture deadlocking. Retry the code and never expose anything out to the users. Yay. It's a win. Now, I have seen it where they retried the code 20 times. Oh, okay, no. Bad, stop. Really, really ignorant. But retrying it 2, 3, 4 times, cool. It may run slower because of that, but you don't return an error. And you can do this on your own and establish your local best practices and get this done. So, having complained about all the stuff that I hate, let me tell you what I like. I like camel case. I use it. I do use uppercase for all my reserve words. It makes it clearer for me, and it just, I can read it that way. It's not some, this is not, you must do these things. Go forth and, no. This is just, I've complained, so now I'm going to let you guys complain back. This is the stuff that I do. I put line breaks on the select list. I put line breaks on my join criteria. I put line breaks between my where clauses. I break it all down. So I've got space around my words so I can see things. Use the semicolon. Yes, sir.
Isn't that going to be required after 2012?
You're getting ahead of me. Yes. After 2012, the semicolon is going to be required. Thank you. That's what I was going to say. The semicolon is going to be required. It's more and more required on more and more commands. And it is required, please, at the end of the statements, not before the with statement. I know a lot of people post their blog, on their blogs, they post their code with a semicolon before the with statement with the assumption that most of you are not using the semicolon and will need it there. But what that's doing is fostering the belief that the with statement requires a semicolon in front of it. It's not. It requires a semicolon as a terminator for the previous statement. And yeah, I get it. Putting it in front of it makes it so it's a terminator for the previous statement. But it's not required to be in front. It's required to be at the end.
What about migration from 2005 or from 2000 to 2012? Because if code is coming from the older servers,
Right.
semicolon will be...
It's, well, I mean, 2012 is not going to require it except on certain commands that are 2012 specific, or the with statement. So you're not going to have to, oh, he was saying if he's migrating from 2000 up to 2012, what does he have to do? Good news, nothing for the migration. Past 2012, I believe Microsoft's going to be requiring it on all commands at some point. Now, Microsoft says things and then they don't do them, so. But that's what they're saying today, is the semicolons will be required for everything. Yes, sir?
Since we're at a Redgate event, can you use the code we developed Redgate has to automatically add semicolons?
Great question. No, I don't think you can. But no, I don't. By the way, ask Redgate tools. That's cool. I'll answer them.
I want royalties for that if you put it in.
Okay. Good luck. I didn't get anything for getting checksum on the backup process. So anyway, indent after the initial select with the on clause after the where clause. And so my query, instead of this god-awful mess, would look like this. I made this name up, but sales order detail info by credit card special. Product ID, credit card ID, special offer ID. I know what these parameters are. I've got a query in here that says, hey, this is important information for the CEO. I'm going to tune this. I'm going to tweak it. I'm going to keep an eye on it, right? Because I know it's important. Begin try, select, where, in try, begin catch. And I've illustrated a few ways that you can catch stuff inside of here. And yes, yesterday has pointed out to me, how much error trapping do you really need on a standard, straightforward select statement? Probably not much. However, what I generally do is create a template for my stored procedures that includes error handling, and then every single procedure gets error handling automatically. Just a good practice. That way the ones who need it get it, and the ones who don't need it, well, they get it anyway, but it doesn't hurt them, so what the heck. Okay? Questions, comments, rocks?
Yeah.
We'll move away from naming here.
If you're picking up someone else's stored procedure, which has all the bad practice, like a long left in on one line, is there anything you know that'll take that and actually format it nicely? That'll buy me.
Hang on. You take American Cash okay? I don't have any pounds on it. Like that. That was Control K, Control Y, and that's a Redgate SQL prompt in action. And yes, it's, God, I can't live without it. I've only worked for Redgate for 18 months, and before working for Redgate, I couldn't live without that tool. And now it's just more, worser, badder, something. Anyway, I really love it. It's one I just, it's installed on every machine. When I set up virtuals and I'm not going to put anything else on, I put on prompt, because I start typing and I'm not getting it, it makes me crazy. So yeah, it's Sure. Not a problem. Writing for performance. These are the topics we'll cover, but don't worry about memorizing all that stuff. We'll get to them. The 3 points I want to make are the right on the top. You have data structures. Yes? I'm assuming. SQL Server people? Okay, the people who aren't raising your hands, I'm assuming you're lying or you're in the wrong room. Okay. You're storing data structures. You have tables, you have columns, right? And when you write your queries, those data structures have data types. They have mechanisms around those data types. You know, dates have date math, all that fun stuff. Please use the data types that you have stored. I get it. Oh, well, we wrote this app a long time ago, and so we stored the dates as strings. Okay, tough. The dates are strings. You must either use those dates as strings, or you need to add another column that stores the date as a date, or X, Y, Z, whatever solution you want to do, but you must implement a solution. You cannot simply ignore the data types. You cannot simply ignore your structures. You need to deal with the structures that you have. If that means changing the structure, if that means some mechanism of dealing with it, great. But you have to do that. You can't ignore it. So write your T-SQL as if the structure you have is actually the structure you have. Because it is. Same thing goes with your indexes. How many clustered indexes do we get? Shout it out. 1. There we go. 1. Why on earth would you bother creating a clustered index on anything, and I realize the default is the primary key, but it doesn't have to be, and then never, ever refer to it? Never, ever write your queries to use the most direct path to your data. Help me, right? Same thing goes with any of the non-clustered indexes. Write them in such a way that you're going to use them. And yeah, I know there's a few tricks you can do where you're putting in some non-clustered index and it causes some enforced constraint that changes the way data is stored. And that's all cool and great. And that means you're not using it for T-SQL. Okay, great. Cool, fine, whatever. But the rest of them, by and large, are definitely going to be stuff that you need to use. And finally, the query optimizer. Microsoft has a team of rather smart individuals who all they do is try to make the query optimizer work better and better and better and better. In general, and again, I don't mean to, this time I don't mean to insult anyone, although I probably will. You're probably not quite as smart as they are. I am not anywhere near as smart as they are. If you are, 1, you should go work for them because they need help. Let's face it, the optimizer is not perfect. But the key point here is that the optimizer is pretty good. Use it. Work with it. Write your code to the optimizer. Work with the optimizer. There are exceptions, and I will detail a few exceptions as we go, but by and large, don't use query hints. Don't try to force your beliefs, not your knowledge, your beliefs that this will make things work better. Unless you've tested it completely thoroughly in every possible regard, frequently query hints make things worse. Much, 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 much worse. And we'll get into that. All right, moving on. Any questions before we go? Yes, sir.
About the cluster index. If you're writing a database for performance in search, if you create a cluster index that is constantly creating, making the pages go crazy, then you will have performance after inserting millions of rows.
Okay. He's saying that if you have a clustered index that you get lots of page splits or page rearrangements, then you're going to hurt performance. You're right. So change the clustered index.
So,
but just let me make one point and we'll move on. By and large, inserts are faster against clustered indexes than they are against heap tables. So a clustered index does not, in general, hurt performance. It is more often helps it, but there are exceptions to that. Yes?
NULL is probably one way to determine and
Right.
make sure that page splitting doesn't
Exactly.
much.
Yeah, I don't want to go too far down this rabbit hole because we can have a lot of fun. But yeah, you're right. Any other comments on that one? Okay, cool. Great. So data types. I mentioned this earlier, mainly because I knew I had a slide for it. I cheat, I admit it. Implicit or explicit data conversions. Either one leads to scanning. I'm sorry, but it does. So that little trick you do where you just ignore the fact that the date's stored as a string and treat it as a date anyway, and it does an implicit conversion, and you're still wondering why the query is running so slow? Yeah, there you go. It is converting that data, and because it converts the data, it cannot use the clustered index or whatever index you have, and it must do a scan. And because it's doing a scan, what's a scan? Scan is reading everything, or at least large sections of everything, and it runs slow. So what are you supposed to do? Use the appropriate data types. Well, let's play. I love playing. I've got a very, very ridiculously simple query. Select these two columns from the human resource table where the employee ID is equal to that number. And you know what? You've got to be in the right database for things to work. Kids, don't try this at home. So, there we go. Nice return. I got it back. My execution time is 0 milliseconds. Who believes it's 0? Steve does. I knew Steve would. Okay, good. It's not 0. It's just within the margin of error, it's 0. All right. And no, it won't be negative either. Ever. Okay. So let's also turn on execution plans. Take a quick look at this one. It's a clustered index scan. Same query, but national ID number is referred to as a string instead of as a. By the way, DBAs. I know I'm supposed to say varchar or car or whatever. I came out of development background. It's a string. Developers, you guys are keeping up. Those guys are thinking I'm a moron, but you're both right. Clustered index seek. Now, performance-wise, how much of an improvement do you think I got? Last one was 0, so 0. Oh. But notice the number of reads went from 4 to 2. Now you're thinking like, yeah, okay, so you're limited to 2 reads. What do I care? You're right, but remember this is 1, an example, and 2, what if this is called 10,000 times a minute? I am now a hero, right? Because I've eliminated half the reads. And the execution plan is it's a clustered index seek. Now let me just point out, in 2012, I skipped over this. 1 or 2 people might have caught it, but I blew past it. In 2012, there's this new little bit. Just make it so you could see it. You might be able to find it. There. There's this new little bit. Now, how's that for zoom it? Anyway, it's a warning that comes up when you're doing, and I'll zoom this in just so we can actually see it, when you're doing implicit conversions. So because I had to do an implicit conversion, the optimizer knows when you did an implicit conversion, it's going moron and does a scan, right? But now it's actually giving you the warning back and saying, dude, just so you know, it's cool if this is on purpose, but you're getting an implicit conversion, and therefore I cannot use indexes properly. Interesting little bit of information. Questions, comments on this? Okay. Oh, wait, I didn't look up. Hands up? No. Okay. It would help, right? Functions in the comparisons. By functions, I mean, left, upper, stuff like that. Anytime you do it in the where clause, in the join clause, and by the way, for the more old school amongst us, on either side of the equal sign, right? I've always heard it say, well, if you do it on the left side of the equal sign, it's okay if you do it on the right side of it. And then I've heard it the other way, if it's on the right side of the equal. No, it doesn't matter. Any function in the where clause, in the join criteria, assuming it's not a sargeable function, will cause scans, which causes slow performance. A sargeable function is I say sargeable and I got corrected yesterday. Sargable. Oh, okay. Sargeable function is search argument able. It reads sargible, and so I say sargible. It's correctly pronounced, I am told, sargible. Okay. Sargible functions. Let's take a look at the code. We gotta play, we gotta play. In this case, I'm doing a really simple select, left. I get my query back, runs well enough, 216 reads, 5 milliseconds. Execution plan is an index scan. That's not cool. So what if we did this? What if we use like? And the same left 4 characters and a percent sign. Query comes back, 3 reads, 0, it's free. And an index seek. And that's just taking advantage of the fact that like, when used with no wildcards or a wildcard at the end, is a search argument able function. If the wildcard is at the beginning, guess what I get instead? Scans. Oh yeah, guaranteed scans. And yeah, if somebody's gonna say, well, how do you get around that? You don't. You can use text, full text indexing, that kind of stuff. But you can't put a percent sign in front of it and avoid the scan at all, period. All right. Questions, comments on this one? Again, smart, quick little things that you need to avoid. Multi-statement, table-valued, user-defined functions. My favorite thing in the world. They're free when you look at the execution plan. I worked for a team that, well, let me roll that back. I was responsible for the production rollout for a team that had spent a year developing this database all on their own, away from me. I never saw it until the day it was going into production. And it was gorgeous. It had multi-statement table-valued user-defined functions that called multi-statement table-valued user-defined functions, which joined on multi-statement table-valued user-defined functions, which called other multi-statement table-valued user-defined functions. And what they'd actually done, and it was gorgeous, they built an object-oriented database inside of SQL Server. And it was amazing. It was beautiful. It was crystalline, and they had it all documented out, and you walked into the room, and they had it all laid out on this big map, and it was, wow, that's cool. I mean, it's just perfect. It's perfect code reuse within SQL Server. And it worked. With one row. Because multi-statement table-valued user-defined functions use table variables. And table variables are exactly the same as temporary tables, except for one thing. Anybody? Statistics. No statistics. So the optimizer assumes one row. And they had tests all set up that inserted data into the database so they could do their testing while they were running, that inserted one row. So it worked. Production had more than one row. A lot more than one row. And the really cool thing was that when I first saw the code and I was like running in circles, screaming like Chicken Little, oh my God, the sky is falling. And they're like, no, it's all fine, it's all good, we've tested it, put it in production. I'm like, nah, I don't think so, this is gonna be bad. And they're like, no, it's fine. I'm like, okay. And we put it in production, and the very first call stopped. Now, I don't mean it blocked or it was running long. It went in and never came back. And it was just sitting there churning away as it went through all these little permutations of table-valued functions trying to find data. And it was horrifically, horrifically bad. And I was very unpopular because I was the one who pointed it out. And then didn't fix it instantly when they, can't you put an index on it? Yeah, it's not good. Now, I'm going to show you an example. You don't have to be insane like that with these 8-layer deep nested things. I've got a really simple one. Sales info, it's going to load up this table variable by inserting into it a select against, it's going to join against 2 tables. Then I've got another one, sales details. It's going to insert into another table variable, and it's selecting from a single table. And then I've got a third function that joins these 2 functions together. So I've got a nice little object-oriented database going on, okay? It's all great. It works cool. And now I can run my query, pass in a couple of values, and it will come back eventually. There we go. It's actually a little faster than yesterday. 1.4 seconds. Oh, sorry. 1,400 reads. 2.1 seconds. All right, in the execution plan, I did get a little table scan here. No big deal. But the function didn't cost anything. It's free. By the way, you know that these costs are, this is an actual execution plan. Okay, this is actual plan. These costs, estimates. Another word for estimate? Wrong. Wrong. Oh, good, good. Guess. Or lie. Don't believe me on the lie part. Okay, hang on. Here's a way to take a look at the execution plan for the function, because that's actually stored. It's there. It's not like you think, you always think, oh, well, it's just a black box. We'll never know what goes on. Yes, you will. All you got to do is go up against the query stats and the execution plan, get the plan handle. I'm getting the SQL text just so we can see it. And then where the object ID is equal to this object ID, combined sales info. This is the combined sales info query function. Sorry. So I run this, and these for some reason have been taking a little while. It shouldn't. This should come back pretty quick. Give me a second. I promise you it will return. I think it's something to do with Windows 8. By the way, Windows 8? Right? Yeah? Yeah? Oh my God. Anyway. Moving on. Table scan, hash match join. Yeah, there's work going on behind the scenes, right? This isn't free. There's all kinds of stuff going on. And then we've got more table valued functions going on. They're happening. And you get to see the table insert. So it's actually doing a whole bunch of processing back there. This isn't free. This is not magic. It's painfully bad is what it is. And estimated number of rows? 1. Let's take a look at the other query. This is the sales details. Again, this will take a second. I just don't know why these are running slow. I'm still blaming Windows 8. There it goes. Well, okay, in theory. There it goes. Clustered index scan, and then a table insert, and then off it goes. These things are horrifically, dangerously bad. They just are. Am I saying do not ever use them? Never, ever. No, I'm not. I'm absolutely not. I am saying use these things very, very judiciously. Go into this really with your eyes wide open, a giant grain of salt, and a lot of testing to validate whether or not this works inside of the environment that you need it to work in. Okay? They're dangerous. They're not broken or wrong or something you should not use. It's just something you need to be very careful about using.
Grant, is there a certain way to write them properly so they actually work?
Yes, it's called a select statement. Let me show you that. If you take a look at the select statement here, we execute this, returns the exact same data. It has almost as many reads, about 800 reads instead of 1,400, but the execution time went from over 2 seconds to 100 milliseconds. And there's actually more stuff, more tuning that could be done on these queries. And I did this, I wrote a bad query on purpose. I mean, not that I don't write bad queries, I usually do, but I spot them quickly. But it's just so radically better. Now, the question that came up over and over again yesterday, and everybody was offended, and I'm going to offend you again, is the idea that you can't reuse code in TSQL, in SQL Server. Guess what? You can't reuse code in TSQL. You can. It's a very interesting function. It's called copy and paste. But really, there's no magic bullet here. There's a few things you can do with some of the inline table functions, so you get parameterized views. There's a few things you can do with views. Also, you can dig a nice deep hole with views, and I'll show you a hole with the views later. But by and large, it's just you can't. Okay, I'm sorry. Hate to pop the bubble, but it's just there's not an easy way to get around it.
Right, the interesting thing there was as well in your query where it's calling the user-defined functions, you actually had a filter on there.
Yes.
So it was doing a lot of work And then you was throwing away 99.9% of the work it was doing.
Yes.
It was filtered on the results.
I know on the result set, I know, which it would be normal function. Yeah, he was saying that because I had a filter on the function did a bunch of work and then filtered the data. So it's like returning, 10,000 rows and then going, okay, we only need 5. All right, I don't have an example for this. The example I would like you to look up is, oh God, I killed that brain cell last night. Help me. Who did one recently? Straight, Jason Straight. God, I got it. Cool. Jason Straight has this fantastic example of this online. So look it up, no lock and the problems it causes. So I am taking away your magic run faster switch. Several of you will remember this. Remember the turbo switch on the 286? Yeah, this ain't it. It does not work. Well, okay, let me rephrase that. It works great. No lock makes it so you don't put locking. When you're doing reads, you can put no lock on and you don't do locks. There's no shared locks on the system. And that is a wonderful, magical thing because it makes everything run faster. True. No argument. How accurate is the data supposed to be that you return? Would it bother your business that you missed rows? He's laughing. Okay, I'm assuming that's a yes. Would it bother your business that rows were duplicated? Okay, a few nodding heads. The rest of you, I don't think you're awake. If your rows are missing, your rows are duplicated because of no lock, your business might just be a little bit upset. And the reason it's going to happen is this little thing called page splits. As data is inserted, splits occur. You're not locking anything, so it's scanning along and a split occurs in front of it. Now, split rearranges storage. It could be that storage gets moved over here and the scan continues and you miss rows. It could be that the split occurs and data gets moved in front of you and the scan continues and you read rows twice. You could be missing data, you could be duplicating data. You are literally putting yourself not into a situation where, oh yeah, I don't care if it says cat or dog while I'm doing an update statement. No, that's not the issue. You are literally putting yourself in a place where you will miss data or duplicate data by using no lock or read uncommitted. It is dangerous. If you need to do this, 1, tune your queries. 2, tune your structures. 3, if none of that's helping, go to snapshot isolation where you can get version data which prevents blocking, which I assume is the main cause of your slowdown. Although if in some instances I've seen other people say, well, no, it's not the blocking that causes the problem. It's the fact that those shared locks, when they're taken out, that takes up memory and we're running out of memory. The shared locks are causing you to run out of memory. Guess what it's time to do? Spend some money, right? Sorry. Spending money solves all the problems, right? If you just buy enough hardware, you don't have to worry about any of this. Query hints. My same favorite team that did the 86, did the giant UDFs, also had someone showed them once a query plan. It's the only query plan I think they'd ever seen in their lives. And it had a loop join. And the guy showed them, oh, this query that you've done, it's running slow because it had a merge join, and I've rewritten it, so now it has a loop join, and everything's cool. And so here's what they heard. Loop join better. Right? That's all they heard. And so they did some experimentation, and they found out if you put in fast 1, all you ever get are loop joins. And loop joins are better. Yeah. And then it was Grant, this query is running slow. Why do we have fast 1 in there? Because it gives us loop joins, and loop joins are better. Okay. Why didn't you just use the loop join hint? Oh, yeah, we use that too. Oh, God. Yeah. When you start seeing really inconsistent behavior, when you really start seeing bad behavior and you don't know why, when you're seeing all kinds of stuff going on inside your store procedures, and you've got this wonderful habit of putting hints on everything, max stop everywhere. Guess what? you need to stop. Let's take a look at this. We've got a nice simple store procedure, selecting a couple of values, we're joining some tables, and by God, loop joins are better. We're going to run that. We get it back. 3,500 reads and 107 milliseconds. And loop joins, yay! Same query, no hints. Funny thing is sometimes this actually runs a little slower. It did, 1 millisecond slower this time. But radically fewer reads, and it had a nested loop join and a hash match join. Now, Oracle people, you're going to like this, okay? This is your moment. Read that. Let me see if I can adjust this and make it more readable. Hang on. Well, no, it's fighting with me. All right, anyway, read that. For each row in the top outer input, scan the bottom row input, inner input, and match it for each, for each, for each. Anybody? Cursor. Thank you, Neil. Your money will be later. I'll get you. For each. Cursor. Oracle people, here are our cursors. SQL Server has cursors, guys. Not those things that say cursor. That's don't touch that, and I'll tell you why in a minute. These are our cursors. Same thing. If I take a look at the hash match join. Oops. Stay up there, boy. Come on. There we go. Use each row from the top to build a hash table, and then scan against each row on the bottom. Cursor. Just so you know. So basically, various types of cursors, just like in Oracle, are here in SQL Server, and the various types of cursors inside of SQL Server give you different kinds of performance. Believe it or not, I'm going to say this, I'll say this out loud in front of people. Merge join is your best cursor inside of SQL Server. It is the best one. It's not the optimal one in all situations, but it is the best one. Because if it gets ordered data, it is able to put it together faster than any of these other cursors can do it. Unfortunately, you have to have ordered data to start with. And most of the time you don't. And it works better with larger data sets. With smaller data sets, these loop joins actually work better, even though they're not as efficient a join mechanism as the merge join. So please take this away. Don't run home and start putting merge join hints on everything, okay? That would be bad too. I have another example of a query hint. Now I know that there's an index on this table. I know I have an index on it, okay? So I'm going to run this query. And I'm not happy with the performance. I got 11 reads, it took 57 milliseconds, and it did this key lookup thing, and I know I don't need that key lookup. So what I'm going to do is I'm going to put an index hint on there and force it by God, to use the index that I know will work. And now my reads went up and my elapsed time went up, but I got the query I wanted. No. What if you just fixed the fact that you were doing a function on the column? Remember those function things? Yeah, don't do that. Suddenly, 2 reads, right? It's simple stuff. It's just simple stuff, guys. All right, recompiles. Which time we got? Doing good. Recompiles. My same favorite team. These guys fed me like you wouldn't believe. I was with all the information and stuff I learned from these guys screwing up. Good question. But they stayed that way for a long time and did a whole bunch of really crazy stuff. And I kept trying to get in, like, what if you just put me on the team with them and we could maybe fix these things before they got to production? Oh, no, we need you. Okay.
Did they kick you out at the end?
No, but I got yelled at every time I said, yeah, see that? That's going to break. But nobody likes hearing that. Anyway, they had their initial fix on the god-awful nested loop joins was to replace them all with views. And I'll show you what happened there. That didn't work. So then the next step was to come up with this mechanism whereby they doubled the number of tables they had and had 86 table joins. Now an 86 table join is pretty cool. You can make them a little bit of tweaking and actually a couple of query hints. You can make it run in about 50 milliseconds. No kidding. Beautiful, beautiful query. Now compile time. 3.5 minutes. And this particular query was one of those beautiful queries, and developers, please don't do this to us ever again. I'm asking nicely. Was one of those queries that was run on every single page, every single time it was called, throughout the entire application. So, 86 tables. Statistics. Statistics get updated based on an automatic process. That includes 10% of the data gets changed. Anytime any of your statistics for a query get updated, you get a recompile. You want to guess how long it takes any one of 86 tables to need a recompile? Somewhere between 12 and 15 minutes on that particular application. And so every 12 to 15 minutes, all day, every day, the app would stop. Because there was a recompile going on the one proc that was called by every single page. Yay. That one was really hard to understand. It was very hard to figure out. Microsoft actually had to help me catch it because I just wasn't seeing what was going on. It was a real horror show. Yeah, oh boy, you just don't even want to know. But the thing is that you need to keep an eye on that because recompiles cause CPU usage, very high CPU usage. Oh, the CPU would peg. And then it causes blocking because you have to wait for that resource to clear before anyone else can use it. So if it's a very highly used stored procedure inside your system, you're going to see a lot of blocking. And you just need to avoid this stuff. Generally, recompiles are caused by one of two things. They're caused by statistics updates or they're caused by interleaving DDL and DML. I'm going to show you real quick. By the way, this demo, it fails. So I'm going to show it to you anyway. Sorry. I've got it interleaves updates against the temp table. Temp tables have statistics, therefore, when you update data against them, you get recompiles. Funny thing is that even though I'm interleaving it in one and not in the other, I'm still getting recompiles because I'm using temp tables. I need to use table variables, but then that would cheat the idea of the structure. So I'll rewrite it at some point and make it better. But before I run this, let's do this. Let's go over here to management. Let's get up extended events. Let's get our sessions up. And, oh, good, I left it running. Our recompile session is running. Let's watch the live data. Execute. Oops, what did I do? Oh, duh. This is what I want to execute, you moron. There we go. And it returns the same data I expect. It queries, blah, blah, blah. But here's where the interesting bit is. This was running slow yesterday, too. Come on, piece of meat. I may need to restart my machine. Have you turned it off and turned it back on again? Yes, I watched that show, even though I'm from the U.S. It's funny. Okay, we're moving on past this. Sorry, bad demo. Mark me down. Null values. I love this part. Guys, null does not equal null. Null does not equal anything. Null is not greater than null or anything else. Null is not less than null or anything else. Null does not contain null, nor does it not contain null. Null is not between null and yeah, null. Well, null cannot be null. Null is null. Null is not null. Or as I was again corrected yesterday, not is null. I'd think about 3 times, but it actually works out. Null functions should be followed because we have null values. Who has a database with 0 nulls? I've seen them. They're actually a bigger pain to use than the ones that have nulls, but because it's like you have to have default values on everything. And it's like, you know, what's the default value on a date that you don't know? Huh? 1899. Yeah, except unless you're dealing with insurance data that's over 100 years old. Darn, can't do that. I tried several things and it just didn't work. But yeah, you get in trouble. So don't do that. I'm not going to show you the demo. It's kind of insulting. Sorry, I don't want to be mean. Row by agonizing row. Rebar. I had to explain what this is. Rebar is what we call the steel bars for reinforcing concrete. Rebar, right? You've seen those steel bars they put inside the concrete? Anybody? Please, nod your heads. Lie to me. Row by agonizing row, rebar. It's when you're doing cursors instead of set-based operations. It's, by the way, while loops are cursors, guys. As a matter of fact, there are cursors that are faster than while loops. So while loops are not the fast cursor. While loops are still just cursors. It's doing multiple statements when you can do things in one. All of this type of processing. Application code is meant to be iterative. Application code is meant to walk one by one by one by one. TSQL code is not. TSQL code is set-based. It really, really is. You need to wrap your head around that or you'll be watching performance die. Okay? Don't believe me. Okay, let's take a look at some code. This one works. So I'm going to begin transaction. I'm going to declare my cursor. I'm going to select some data out of my database. And I'm going to look for anything that has a weight less than 3. And then I'm going to update the color to blue. And then I'm going to fetch the next thing. And then I'll deallocate my cursor and select star where everything is blue. All right, now let me get this started running. Okay, now these things can run kind of slowly. And you may have to wait on stuff to occur. But usually it'll finish at some point. Executing. And then we can talk about what it's doing. Oh, crud, I forgot. And one other thing. We need to make sure that we need to, we're very concerned about the update statement and whether or not it's using the index. So I need to look at the execution plans, and I'm going to capture the update statement. And as soon as you guys see it, you just shout it out, okay? Because I need to find that. Anybody seen it? Keep looking. We're going to find the update statement. Maybe. Hang on. All right, I give up. We're going to stop. Believe it or not, that is the demo. No. No, no, no. No, no. All right? What do you do instead? Crazy thing, we're going to write TSQL. Done. And I got an execution plan. Contrived example, yes and no. Because I've seen code exactly like that. Multiple times. Not once. If I saw it once, it would be an interesting story. The fact that I see it a lot means it's a pathology. Okay? Stop. Don't do that. All right. Nesting views. I told you I was going to take away all your toys. This is the other one. Views are cool. And the optimizer works really well with views. Let's say you have a view, references, say, 9 or 10 tables. And you run a select statement against that view. And I said tables, right? 9 or 10 tables, right? And you run a select statement against that view. And you're referencing 3 or 4 columns. And come to find out, the optimizer identifies that those 3 or 4 columns, it can get from, say, 3 of the 10 tables. And it doesn't need the other 7 tables. There's a process inside the optimizer called simplification, in which case it will throw out those other 7 tables and say, I don't need these to retrieve this data. And then you will get a very quick little plan that retrieves the data that you have. That is assuming the optimizer has enough time to get that done. If the optimizer is dealing with views that join against other views. Now instead of 10 tables, you have 36. And oh, by the way, it's not all tables, you've also nested views because we're doing code reuse. And you've got views inside of the views, and views calling the views, and views joining on the views. And remember my function team? Yeah, their first method to fix it was, well, we'll just replace, because they did it with a little code update, they just replaced all the functions with views. And it, and they tested it with 10 rows. And it, grant, we tested it with 10 rows this time. And it works. Yeah, no, it didn't. The optimizer was no longer able to come up with decent plans, and so what it does is it gives up. It just says, you're on your own. You're referencing 86 tables, or, yeah, it was 86 tables through these views. Cool. Here's your 86 table join. Talk to you later. It just didn't even bother trying. It did a timeout, and it kept going. But it doesn't have to do a timeout, even. You can get it with very simple stuff. So we're going to create this view, sales info. It's going to look very familiar because it's exactly the same. I basically took the functions, and I'm recreating them. And so if I do this, and run the view. It comes back in a reasonable period of time. It's 1,000 reads, 131 milliseconds. It's not that painful. And the execution plan is referencing, excuse me, the execution plan says 0. It's not right. Execution plan is referencing 2 tables and doing clustered index scans. What if, I don't know, crazy idea again, we just did a query against the table itself to retrieve the one piece of data we want. Now it's a clustered index scan. And the reads have been radically reduced and the performance has been radically reduced. And that, my friends, was simplification doing a good job. Instead of the 3 tables that were referenced, it only boiled it down to 2. So the fact is that even with simplification, you're not going to get a magic hit on performance. You're not going to get magic benefit on performance. You're going to get hit. Okay? I'm sorry. It's just, I'm taking away all the toys, but it's how the machine works. You know what I mean? This is SQL Server. It's not me. I'm not mean. Okay, yeah, I'm enjoying myself, but I am mean. But it's not that. It's SQL Server works this particular way, and you need to work within it. So hopefully we hit the 2 goals. We talked a little bit about readability to improve your performance, and then we talked a whole bunch about TSQL to improve its performance. Remember, writing for readability, your standard, not mine. Do object naming, do comments. Please, please, please format it. Don't pile it up. Document it. Do code reviews. Whatever you do, don't diddle-tibble, okay? It's just a horrific thing. And here's my contact information. And if you have any questions, we've got a couple of minutes. I know that technically the session is ended, but there's like a half-hour break. So if you want to spend like 3 minutes in here answering some questions, we can do that. Yes?